So let's break down the cross-bridge cycle. I always like to start without the cross-bridge being formed, so we're going to focus in on this part right here. Here is your thick filament, there is your myosin head, here's your thin filament made up of individual molecules of actin. And what can we see? There is a gap in between the thick filament and the thin filament. This gap means that there is no cross bridge that has been formed. If there's no cross bridge formed, there's no force being generated. Okay, first thing that happens is an ATP molecule becomes available. That ATP molecule is going to bind to the myosin head at the ATP binding site. And remember, what is ATP? It is going to be a source of energy. Now, the energy from here is actually in between the second and third phosphate. So what we're going to see is a splitting of the ATP. We're going to see the ATP being transformed into ADP plus P, and that brings us to our next state. So in our next state, here is our myosin head. We can see instead of ATP, we have an ADP. We'll just draw that there. We have an ADP connected. We also have a P connected. And so what we can see is we broke the bond between the second and third phosphate. Because of that, we actually changed the shape of the myosin head. At rest, the myosin head kind of looks like this, but if you break the bond between the second and third phosphate of the ATP, you can actually stretch out the myosin head just a little bit. If you look really closely, you can actually see available myosin binding sites. They're these little dark circles. Now, usually when your muscle is at rest, you actually have this tropomyosin molecule blocking. So if this were blocking, you would actually see tropomyosin cover up each of those spots. But we can see there is some calcium that is going to be here. The calcium is going to bind to the troponin. It's going to pull the tropomyosin away. So we are ready to make our cross bridge. That gets us to our next stage where we actually form the cross bridge itself. How can you tell? Well, here is your myosin head. It is connecting with one of the myosin binding sites on the thin filament. Here is where we actually form the cross bridge. Here's where we get some of that force being generated. We have spent the energy to stretch out the myosin head from a resting state to a stretch out state. But now we have a stretched out myosin head. We have A, D, P, and P connected. And all we really need to do is move on to the next figure. In class, I mentioned one of the first things that happen is that phosphate is going to basically get kicked off and it's going to leave. When we actually get that phosphate leaving, this cross bridge gets incredibly strong. When this phosphate leaves, you're increasing your grip on that thin filament. The second thing that happens is then this ADP, that's going to leave. And when we actually get the ADP kicked off, that stretched out myosin head actually reverts back to its original position. This is what we refer to as the power stroke because this is what is actually generating the shortening of the sarcomere and the shortening of the muscle. So the end result here is we're going to have a relaxed myosin head still forming a cross bridge. And now what we need to do to continue the cycle is we have to break this cross bridge. Now, the way that we do this, as you can tell as we move back to where we started, is we need another introduction of ATP. And what happens when this ATP molecule binds to the myosin head? That releases the myosin head from the thin filament. It breaks that cross bridge. We do need an ATP molecule to connect to the myosin head, but we do not spend that energy to break this cross bridge. It just breaks on its own. And very conveniently, we now have an ATP molecule connected to the myosin head, and we can split the energy in the ATP so that we can continue the cycle to basically stretch out the myosin head, make that cross bridge, so on and so forth. So that is the entire cross bridge cycle.